Okay, so recording, and we're looking at the solutions for the transformations worksheet, so worksheet number 2. So in breakout rooms, we did 2, 3, 5, 6, 7, 8. So for number 2, again, you have negative f of x. So you have to flip that graph over the x-axis, so all the y values get multiplied by -1. So you had a point at 0, 2, now you got a point at 0, -2. You had a point at 2, -2, now you have a point at 2, 2. Of course, -4, 0, -4, 0, 3, 0, 3, 0. So naturally, you just multiply the y values by -1 and plot the new points, or you can just technically flip the graph over the x-axis. For 5, however, you're flipping over the y-axis, so the x values get multiplied by -1. The y values stay the same, the x values get multiplied by -1. So instead of -4, 0, you got 4, 0. Instead of 3, 0, -3, 0. Instead of 2, -2, you have -2, -2. Instead of -1, 1.5, 3, yeah, -1, 1.5, you have 1, 1.5. So all the x values get a sign change, which causes the graph to flip over the y-axis. That's that transformation. 3, hopefully, is pretty straightforward. That's a shift of 1 right. It seems a little counterintuitive with x minus 1 inside the parentheses. That's actually shifting 1 right. So you're adding 1 to all the x values. So all these x values you see here. So try to pick like a few key points and adjust the points, adjust the coordinates according to what you're seeing for the transformation. 6 is a little funky. You would think to multiply by 2. It's actually counterintuitive. You actually divide by 2. So the x values get divided by 2. The reason why that happens is that if you want f of 1, then x would have to be 1/2, which means that you're actually dividing your x values by 2 to achieve the same thing you had from the original graph. So the y values stay the same, but the x values get divided by 2. So that's what's happening with that one. So you take your x values and divide them by 2. So instead of -4, 0, -2, 0. Instead of 1, 0, 1/2, 0. Instead of 2, -2, 1, -2. Instead of -3, 0, sorry, instead of 3, 0, 1.5, 0. So everything gets kind of smushed like that. So the x values change, so the y values don't change because you didn't impact y at all. You impacted x. That's what happened. Another way you could probably, trying to think of how else we can probably think about it. I mean, if you were to make a table, I'm not sure if that would help maybe. Let me think here. Obviously, when x is 1, we know 0. X is 2 is -2, and x is 3 at 0. So now we got to put whatever. So now this is going to be f of 2, which of course equals -2. So that's why you have a point at 1, -2. Okay, I think that could work for us. Obviously, this will now be f of 4, but I don't see f of 4. So what if I looked at 0.5? On the original graph, f of 0.5 was 1. So we'll kind of ignore those lines there. But so now if you do f of 2 times 1.5, sorry, f of 2 times 0.5, which of course is f of 1, f of 1 we know is 0. So that's why we see a point at 0.5, 0. So you can still do that same process of making a table, but I think it's better to visualize it and just realize, hey, I'm just dividing these x values by 2, and they just come in. For 7, you're actually going to be giving the positive y values. So the y values have to all be positive. Now in the original graph, were all the y values positive in the original graph? Yes or no?
No.
No, right? So what happened to that portion? What did the transformation do to that portion?
You kind of put it on the positive side and make it go up.
Flip it over the x-axis, exactly. Was this impacted? No. Here you leave alone. Here you flip. So when you see an absolute transformation, it actually takes all negative y values, make it positive, and anything that was very positive stays where it is. So that's what's happening with that one. And lastly, I know number 8 is not shown here, but the way that's going to look. So remember, we had a point right here, we had a point right here, we had a point right here, we have a point right here. So that was the right side of the graph. And remember, you're doing this, y equals f absolute value of x, right? So, of course, f of the absolute value of 1 is the same thing as f of 1, right? It doesn't change. So the right side stays as is. But if you do f of absolute value of negative 1, now that's going to be the same thing as f of 1. So at negative 1, I think we know something like this over here. That's not going to be true anymore now. It's going to repeat what's on the right side. So now the graph becomes a mirror image of the right side of the y-axis. That's what happens there. So that's the transformation, is that you take whatever was on the right side of the y-axis and repeat it on the left side. So whatever was on the left side originally is totally irrelevant now because you do an absolute value of x. So now your input's always going to be positive or 0. So those are a little more tricky. And we'll talk more, we could talk more about this. And if you want to come during office hours or stick around for a couple minutes after class is out, you're more than welcome to. Okay, so let's keep moving because we only have about 6 minutes left. I do want to just talk a little bit about page 2 of the 2.1 notes. So I'll clear. And if we go back to the 2.1 notes, we did have that discussion about left and right hand limits. And we did talk about that we don't care what the actual value is of y at x equals whatever we're approaching, because we're all about approach, not the exact value. But I'm going to kind of cover more of this in a video. Let's look at example 1. Let's spend some time on that. And actually, I'm going to focus on C, D, and E right now. So when you see that little plus symbol, we call that a right-hand limit. When we see that little minus symbol as a superscript, we call that a left-hand limit. So if we focus on this graph here, I'll get a little spotlight. And if I'm getting closer to 2 from the right side, so this means that like x could approximately be 2.000001. It's close to 2, right? As I get closer to 2 from the right side, what is y getting closer and closer towards?
1.
I'm approaching 1, exactly. And actually, it is 1 when x equals 2, spot on, but I don't care about, I care about what approach. It totally is going to equal 1. Now, what if I'm approaching 2 from the left side? So like now approximately x could be like 1.999999999, right? What if I'm approaching it from the left side?
It's 4.
What? I'm getting closer to 4, exactly. Now, here's the dilemma. When you don't see a superscript, you assume either side. Or actually, sorry, assume both sides. So the LHL must equal RHL for the limit to exist. Well, did the left-hand limit, which is 4, equal the right-hand limit, which is 1? No. So we say D and E. which is shorthand for does not exist. So they don't link up. And this is a topic we're going to see often and talk about often and explore often. So don't worry if it's still if you're still kind of getting your bearings straight and you're still a little unsure about it. You will be more sure about it when we do more and more of this. But you can see visually that as I'm approaching, if I'm getting closer to x equals 2 from the left side and x equals 2 from the right side, these two portions of the graph do not link up. When they don't link up, the limit does not exist. First when I started teaching calculus over a decade ago, people would quote something from the movie Mean Girls. I think there's some part in that movie. I've never seen it. So maybe one of these days I'll watch it. But I guess there's one quote where someone says limit does not exist. I don't know. So if that's where you may have heard that, I don't know. Anyway, I think that movie was popular a long time ago. But CDE, those are the answers. 1, 4 does not exist. Now, how about for A? What if I'm approaching 0 from the right side? What is y getting closer and closer as I'm approaching 0 from the right side?
0. It'd be 0.
Always 0. Yep. And from the left side, the same thing's happening as well. Now, I didn't ask that question, but if the left-hand, right-hand limits are the same, we kind of already talked about that. If those are the same, then you just say 0. I mean, for this case here, obviously. It'll just be whatever both left and right-hand limits are approaching. Just like we saw in the first page, the left and right-hand limits are both approaching 4, so the limit was 4 when x approached 3. In this case, when x approaching 0, it's 0. And then pretty much time's up, but let's just do these two really quickly here. Let me erase some of this other stuff. For F, so x is approaching 3. So sometimes you just say what the y value is. It's just 3. Or here, it's approaching -1. Sorry, as x approaching -1, y is going to be approaching 1. Now, there is no left side. That's not part of our domain. So in this case, you just use the appropriate one-sided limit. Which of course is just the right hand, and that's approaching 1. But these are all things we'll explore, continue to explore next week. So homework, I'm actually going to be assigning 2 homeworks. They're going to be called homework number 2 and homework number 3. Homework number 2 will be some textbook stuff on what we just did, and there'll be worksheet number 1 with a video. So there'll be a video on worksheet number 1 where I kind of explain the beginnings of it, and then you'll do the rest of the problems. There won't be a Google form that goes with it because you're just doing a worksheet to supplement that video. And then there'll be some textbook problems dealing with this stuff. That will be due on Monday in Schoology. If you turn on Tuesday, not a big deal, but just so you don't fall behind, I'm going to make homeworks that are relevant to what we did on Thursday lessons due on Monday. And then Monday is that kind of like the asynchronous. I know Monday's Labor Day, I get that, but I'm going to keep the train moving here. Monday's supposed to be the asynchronous day. You're supposed to watch videos. So I'm going to put a video that covers more of 2.1, and there'll be a Google form that goes with that. So it'll be very clear. They'll have the due dates on there. Just do it over the weekend. If you get them all, if you don't turn something on Monday, if you turn everything on Tuesday, that's fine. It's not a big deal. We're not going to penalize you. In fact, actually, I think we're not supposed to penalize you for any late homeworks as long as you get them in the unit. Because we know this is kind of a unique learning experience. But just so you don't fall behind, try to follow the deadlines if you can. So I'm going to, by tomorrow morning, I'll have some videos ready. I'll have like textbook problems stated. I'll take pictures. We don't have the textbook. Don't worry about that. I'll tell you like what worksheets do. So I'll be very clear. I'll be available office hours tomorrow morning and Tuesday morning as well. I know it wasn't available today, but now I will be. So, or if you have just random questions, just ask me. I'll email, I'm filled by email. So sorry for taking a little long. We're supposed to end about 3 minutes ago. So enjoy your lunch, and I'll stick around for a couple minutes if you have any questions. All right, see you guys later.
Yep.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.